This is very depressing. Why was the microphone turned off initially? Why? That's so annoying. Okay, I'm an idiot. That must have been very boring. Um, yeah, well, we're back. We're back in business. Um, we're back in business. We're back in business. All right. Speedy memes in the chat, everybody. That's Oh, this does turn out to be 0.567, so I seem to have done it right, which is good news. 56.7%. For anyone who couldn't hear me, which is of course everyone, the way you do that is you work out if you like had one of every item, right? You work out the amount which is recyclable out of everything. It's like 680 grams on average is recyclable for Dove body wash and such. Um, and it comes out to this. Now the problem with this claim is that this only works if you assume all the items exist in equal counts in New Zealand. This is quite untrue, as I am sure that the number of, I don't know, the number of, I don't know, Pringles chips is probably greater. Was it? As I'm sure that the number of each item will vary from item to item. So this causes the distribution of items to not be even, and such the claim falls over. I guess a good way to say this would be to say, for example, imagine if everything, or nearly everything, was pick Pringles chips, right? Was Pringles. Then the probability that we have a recyclable item is near zero, because Pringles chips aren't recyclable at all, right? So if there's way more of one item, then yeah. Who the heck? Why have we wrote 6-7 in the chat, lads? That is, it's not. It's 50. Ah, I see. Made a cardinal sin there, haven't I? All right, that's boring. Let's move on. See, why can I get this image, but I can't get the actual graphs I need to complete the exam. It's infuriating, man. It's really, really annoying. Um, yeah, pretty crap. Anyway, um, God, this is getting miserable. Nico, ring me on Discord if you're bored, because I need help. A student observed that many packaging products in New Zealand were only partially recyclable. Okay, that's fine. Um, the plunger cap is not recycled, must be removed before recycling the bottle. Okay, sure. Please know which part. Okay. The scan products barcode shows code consumers which part of the suitable recycling should occur on. Alright, I agreed to separate the discarded packaging into recycling and landfill each week for 3 months. The household friendly elegant. Separating discarded packaging with the use of the app or without the use of the app, participants discarded packaging. We're clearly analyze them into recycling packaging each landfill was recorded. Oh my god, a whole bunch of bullshit. Right. Oh no, it's the bootstrap question. It's so far out of the confidence interval. What the fuck? That's crazy. Alright. Okay. So there's definitely a claim you can make here, I think. Um, so with no app, so about 36% or something. It's 4.16 percentage points higher for no app than app, which makes sense, I guess, right? Because then you're gonna have, um, you're gonna have more people just throwing out random garbage that they really shouldn't be. Um, just not ideal. It's really not ideal. Wonder, can I get the stream chat? Can I get this to overlay? Ah, I can. Or I can't. That's unhelpful. Stream chat. Okay, there we go, there we go. And then can I close this? Alright, I can put that up there. Huge. Alright. Okay, So, discuss what we concluded from both the features of the sample data distributions and the re-randomization, including any reasons you might have about setting any findings from the results. Jesus, alright. Well, oh, there goes the chat. The observed mean difference in proportion between the amount of recyclable items thrown out is 4.16 percentage points. 4.16% percentage points. And the data is pretty it's pretty symmetrical. The data for both distributions is pretty symmetrical. It's almost rectangular, eh? Like you could, no, not really. But yeah, it's pretty symmetrical about. Pretty symmetrical about the respective means. Yeah, so like it's the middle there, middle here, middle here. It's reasonably symmetrical. But there are two, in each there are like a peak. But in each there seems to be a peak about 10% to the left and right of the mean, indicating a bimodal distribution. But now bimodal distributions are quite rare actually. So there's a peak, sort of a peak here and a peak here, and then a peak here and a peak here. So bimodal distributions are they indicate there's something wrong with the data, or something's influencing it within the groups, which is interesting. Not sure what that would be. Okay, re-randomization test output. Well, the re-randomization test shows us that exactly, I'm going to be very precise with this, the square root of fuck all results came out with 4.16 percentage points difference in mean. So i.e. if we're too slow to understand what the square root of fuck all means, 0 out of 1,000 equals 0. This is pretty strong evidence that the observed difference is not simply just chance, and hence the claim is supported that users without the app will throw away recyclable material more often than app users. You can say something like that. I mean, seems reasonable enough to me, I think. Don't really know what else we would want to do. Don't think it's too bad generally. I am interested what happens when this reaches an hour, because apparently it's like, it might just break. If it does, I'll just start up a new stream and we'll keep going. So, yeah. Okay, and then any reservations we have about using this claim. Okay, so let's look back at the data, right? So, households with volunteers. Households with volunteers, not randomly selected, so may not be a true and fair representation of the total population. Hence, wonky data, right? Or hence sus. I'll just say sus data. That's good enough for me. What else could you say? it's possible some households simply got lazy over the course of the 3 months and started not separating items properly, knowing that they were being surveyed may have influenced their decision making, i.e. more likely to consider whether something is recyclable, hence, SAS data. That would be, sounds good enough to me. If anyone disagrees with that, you can take it up with someone who's not me, to be honest. Can't be bothered. Why is it showing all the way back here? 1 hour 50. Yeah, whatever. Alright, that seems fun to me. Ministry of Environment estimated 1,000 New Zealanders were given a list of lifestyle tweaks. Hooray! Can't see the graph. The Great Recycling Delusion. There's not even the confidence interval's fun. Okay, hang on, let's see. The Great Cycling Delusion. Okay. Great Recycling Delusion. NZGeo. Okay, good start. Top 13 answers with the proportions below. The correct order of effectiveness is shown on the right of the figure. Okay, is this the figure? Can someone tell me if this is the figure or not? Yeah, I do need to know. I think my stream delay is a little bit... Nico's running away. Oh wait, fuck. He rang me. Oh, sorry. I presume this is the graph. It says top 13 answers. Yeah, okay. This is asked to put the three that I believe would have the biggest. The correct order of the effectiveness is shown on the right side of the figure. So switch to renewable power. Recycle. Wait, what? What's it? Is there any more graphs? I believe this is the graph, right? It is. Okay, someone says it is. That's good news. Trying to understand. Shown on the right shows figure 5 shows the top 13 answers with the proportions below. The correct order of effectiveness shows. Okay. Buying products with less packaging will have more of an impact on reducing the effects of the climate crisis than recycling will. The 95% confidence interval and evaluate the claim. Shit, right, how do you do this? Get the margin of error, and... Yeah, alright, okay, so... I've forgotten how to do this actually. Margin of error is plus or minus 1 on the square root of 1,000, yeah? So that's 1 on the square root of 1,000 times 100. 3.16%. And a high proportion of New Zealanders consider recycling to be more affected. Oh, but it's margin of error for a difference, right? So I guess we could say something like more effective at reducing the effect of buying products with this packaging. Proportion considering recycling more effective equals what's it, 33 is it? 33% more effective recycling effective relative proportions. Okay, and then you can say proportion considering buying products with less packaging equals 28%. Okay. So the difference is 5%. Observed difference. But your margin of error doubles here, right? Because it's like a margin of error for 1. It must be, yeah? Actually, I'm just going to Google this. Margin of error for a difference in proportions. 2 times... No. Oh, hell no, bro. 1.96 here. That looks like hell. I'm presuming it's 2 times. Someone yell at me in the chat if it's not 2 times. But I'm pretty sure it's twice. Right, so this should be 6.32%. Because it could be, this number's 33% plus or minus that, right? And that number's this plus or minus that. So like at the extreme. So therefore the 95% confidence interval for the difference is, so it could run from minus 1.32 to 11.32. So I guess the interpretation here is the difference could be such that people buying products with less packaging is 1.32 percentage points higher than the proportion of people who believe recycling, right? And recycling, or it could be up to 11.32% that proportion, or it could be that the proportion of people who believe in recycling or whatever is 11.32% higher than that of those supporting buying products with less packaging. Right? The claim is not supported as the interval runs through 0%. Makes good enough sense to me, to be honest. I doubt they're going to run into any issues there, no? 133.37, yeah, whatever. That sounds good enough to me. Okay. Investigating the results shown in Figure 5, the student argues that the effect that renovating your house efficiency will have on your environmental impacts depend on a number of confounding variables. So student argues that the effect that renovating your house for efficiency, that is how energy efficient the house was in the first place, to renovations, okay. How effective the efficiencies are in different environments. Student also argues that efficient renovations may even result in less desirable changes. What happened indoors with air conditioning during warmer weather, which is energy efficient appliances. Alright. They suggest that the many education conduct a survey, a study to see how effective. There's two methods on any conclusions that could be made. A sample of New Zealand households recently renovated for inefficiencies at random. Each household is categorised based on pre-renovation energy efficiency in the home. Energy efficient, non-efficient energy is calculated and weighted to take into account the size of the house and the number of occupants living in it. The results of the study are analysed in the bootstrap columns until constructed. Randomly selected. Okay, well, study A uses random selection, while study B uses volunteers. Re-randomization test. Well, re-randomization test and bootstrap confidence intervals are the same thing, basically, surely. We'll go with it. Yeah, alright, so renovations and no so now it's renovations and no renovations. The renovations group each undertake an energy efficient renovation. The no renovations group do not renovate at all. Energy usage is calculated and weighted taken into account using volunteers. So study B may not be a truly fair representation. Something like cleaner people, or not cleaner, more energy savvy people may choose to volunteer. Okay, so what does study A do? Study A groups in two levels. Energy efficient or not. Then they're measured. So then the measured energy usage is calculated and weighted. Okay, so this gives a solid indication of whether the energy usage depends on whether a group is in energy efficient or not energy efficient. Okay, so study B, however, right? Study B groups, however, by renovation. Yeah. Now, study B is much more. People in study B are much more aware of what's going on, right? The people in the energy renovation group are well aware of the study and have volunteered, and the renovations group is energy efficient. Alright. And have volunteered. So I find it likely that people in this scenario will actively try to be more efficient than usual, which means sus data. And also there isn't much to be said about non-energy efficient houses in study B, as it didn't group by them. Yeah. Hence, study B cannot make claims about what non-energy efficient houses use. it seems something like that, I'd say. Seems reasonable. W stat segment. I no idea what that means, but you know, whatever. Um, haven't got a clue. Um, yeah. Question 3. Oh, for God's sake, why are all the graphs so annoying? Figure 3. Oh yeah, no, I reckon we got a pretty solid N1 for that. Figure 6 shows a scatter plot comparing. Well, it doesn't show anything, but whatever. Just for inflation and difference. Color has been used. Great. Okay. Well, our world and data per capita waste. Or maybe I can open the file. My God, it's a long exam. Oh, okay, that's good. I presume this is the graph? Scatter plot? Oh, wait, it's not. That's over here. Yeah, okay. Indicate the continent each country belongs to. Oh, yeah. Okay. Alright, that's pretty cool, actually. It's pretty solid. Identify at least 3 key features, including a brief discussion of how per capita plastic waste compares for 2 different continents. Identify 3 key features. Well, Jesus, alright. Uh, hmm. There appears to be a I'm gonna say linear, but maybe it's almost quadratic. I'm gonna go with linear. To be a linear relationship between GDP and per capita waste. Kilograms per person per day. In kg per person per day. This indicates that as GDP increases, so too does the country's waste. Seems like a fair first comment. The use of color as a feature that allows users to make judgments, I guess, judgments/claims. For instance, one can notice that no, fuck's sake, bro. I'm colorblind, so I just get cucked by this. Oh, you can hover over it. Okay, my savior. One could notice that Africa tends to be, Africa has quite a large amount of countries in the lower left, so low GDP and low waste. I guess that makes logical sense. While I bet you it's Asia, right? It'd definitely be Asia. Not racist, but oh no. Oh, it's actually Europe. Yeah, no, should have seen that coming. While Europe has a large amount of countries in the right hand side with, well, actually, that's actually quite interesting, actually, with a with higher GDP, but actually a surprise quite a similar plastic waste rate. That's actually kind of shocking how similar that is, right? You got Africa, right, and then Europe's just down. Yeah, there's a few outliers high up, but there's plenty that are quite low. Yeah. What's another key feature? Who knows? Something of interest, surely. Um, yeah. Another key feature of the graph. Oh, the GDP is plotted logarithmically. Oh wait, this invalidates my first claim. It appears to be a exponential relationship. So right, because it's a logarithmic graph. So there's actually an exponential relationship in disguise. It's plotted logarithmically to make the graph easier to interpret, i.e. countries are not bunched together. That's a feature, good enough for me. All this extra space. Definitely supposed to write more than that, but who cares? The occurrence of microplaces and saltwater bodies relative austerity, but little is known about their presence in most of the commercial salts. From 17 salt brands originating from 8 different countries. Jesus, alright. www. Alright. I gotta crunch this open. God, it's a long exam, isn't it? Okay. Come on, where's the graph? Is this the graph? I should be able to work this out. Presence of microplaces and commercial salts from different countries. No, it's not that. Must be this one, right? Yeah. Alright, should be this graph. That's fine. Calculate the mean size of microplastic particles. Larger than 149 micrometers. Okay. Particle number. Okay. So, mean size. Is the mean size the particle number? Like, is that what I'm looking for here? Is this the right graph? Someone could tell me if this is the right graph. This would be very useful. Well, that's whatever. Calculate the mean size that were extracted. Well, what do they mean by size? They mean, is that what the particle number means? Oh, this is particle size, right? Histogram of number of a particle number of particles. Okay, I'm actually not too sure what they're trying to what they're getting at here. To be honest, someone tell me in the chat. I'll come back to it. Model the size. Oh, what, you're gonna get like a line. Okay, so it has to be real easy then. Calculate the mean size. Not that one. Excellent, it's not this graph. Uh, oh, that's all. Which graph is it? Is it just this? Like, not, not really sure what I'm supposed to do here, man. Rather unhelpful, to be honest. What am I looking at? Hmm. 149 we extracted from the 17th. So, well, I mean, without seeing the damn thing. 74 microplastics. 17 different salt brands originating from 8. Is it just... Looks like the first figure. Okay. Calculate the mean size of... across different sizes. What? The mean size of microplastic particles larger that were extracted from the 17 salt brands. How? Okay, I'm just gonna move on. I'm sure it's some easy solution, but I can't be bothered and my head hurts, so stuff it. Use normal distribution. Normal distribution, mean of well, I don't know what the mean is. Well, I'll pick a mean of whatever the previous answer was, mean of whatever, and then standard deviation is the width of your interval divided by 6. So whatever that is. You can't use normal distribution here, right? Surely. That looks normally distributed. You can usually use normal distribution. It seems fine. Don't think that's going to cause any issues. Not being able to see the data is really screwing me over here, but each is described as 74 microplastic particles. Could we use Son? Research is 70 larger than 100. I feel like I'm really missing something on the graph here. There's just something fundamental I'm missing. Because it says adapted, which means it's not the same graph, which means it's just some piece of information I'm not getting. Some kind of code. I mean, you just use your calculator here. Can you do like triangle? I guess you could totally do triangle, right? Triangle set mode equal to your answer to part I, and then endpoints. And then here you just justify whether both of those work by calculating. I kind of screwed because I can't see the graph, so I'm just going to give up on that one, unfortunately. Macroplastics are pieces of plastic that are over 5 millimeters in size. They may include waste such as bottles, bags, packaging materials, scuttling fishing equipment. Huge. Alright. Sheltered beaches. Well, I mean, like, nothing can really be made, right? Like, it's very much just due to chance that this happened. No conclusions can be made, as it is very clear from resampling that the observed difference lies somewhere in the confidence interval of 0.79% below to 1.49% above, which could mean one is higher than the other, or vice versa. It's purely down to chance. Also observe that nearly that 0.37 fits, like, pretty fits, like, very snugly into the middle of the confidence interval. Oh, of course it does, yeah. That's kind of stupid. Yeah, I mean, like, that's a... Oh, it's so long. Like, what are you supposed to say? That's it. You can't make a conclusion. You can't conclude anything. Um, yeah, there is no statistical evidence to support the claim that one beach contains more microplastics than the other. Seems fine to me. Question 4, alright. In April 2025, a nationally representative sample of 122 respondents were asked questions about recycling and waste reduction. Respondents reported their age and the actions they took towards reducing their household recycling, including which bin they used when they were uncertain whether or not an item was recyclable, whether or not they had curbside recycling collection in their area. Alright. Almost always age and years. Hang on, okay, so age and years. Sometimes or never, almost or always. So very, very even distribution. Sometimes or never is pretty. Which bin, when uncertain about recycling? Rubbish. So substituted by actively recycle. Okay, so yeah, I mean, only one person here is, yeah, and see that there are, of the people who never actively recycle, only one of them screws it up and puts everything in the recycle bin. Of the people that do actively recycle, all these people just put the rubbish in the recycle bin. So really what they're saying is they're actively recycling, but they're actually just putting rubbish in the recycle bin because it's their respondents. That's kind of poor, actually. Which bin, when uncertain about recyclability, by actively recycle? So yeah. So if you almost or always put it in the rubbish, just yeah, sometimes I'll never. Okay. Describe what the plots reveal. Okay, there's a few things. People who actively recycle. People who actively claim to recycle are actually much more likely to simply throw everything in the recycling bin when unsure, as opposed to the one guy who doesn't actively recycle, making the same error. Okay, that's something you could say. could say uh, having curbside recycling indicates that having curbside recycling indicates a greater likelihood of someone actively or almost always someone almost always actively recycling as opposed to the people who do not have curbside recycling. Curbside recycling. Yeah, that's also true, I guess you could say. People do that. This indicates people are lazy, won't recycle unless convenient. And it appears on average older people are more likely to actively recycle more than younger people. You can see this from the mean, right? Almost always greater mean. What else could you say? Yeah, it's the same conclusion, right? That's about all you can draw, pretty much. Not a whole lot of excitement there, to be honest. Curbside recycling of food and green waste. Well, it checks out from the lazy perspective, i.e. with curbside green waste, it seems lazy people may now be spurred on to appropriately disregard their green waste. That checks out, I reckon. Seems chill to me. You got 54 stream views, huge. But you can't really. This is, however, a different type of rubbish / waste, so we must consider how similar trends would be. Well, if you yeah, I mean, that's sort of it, right? Presumably, the curbside equals greater likelihood of appropriate disposal. Theorem will hold for green waste if it held for recycling. Hence, it is a reasonable shout. Whatever, that's good enough. The curve size, each household is 3 bins, a red bin, it's going to be a 3-circle Venn diagram. Mean weekly combined weight of all recycling emission gas produced by individual households 11.46. Number of households. Well, so trying to work out how big the sample space is. Suggest that the mean weekly combined weight of all recycling. So it's going to be like the total weight divided by x equals 11.46. Okay, but the total weight, yeah, okay, so we're going to be a little careful here, right? Assuming the weight of a bin not presented curbside is equal to a bin presented. It's going to be a crucial thing to assume, right? If you just for rubbish, total rubbish, the total weight will be 1552 divided by 0.83. 1552 divided by 0.83. 1869.88. For rubbish, you'd get 936.1 divided by 0.73. Not rubbish, I'm recycling, sorry. 1282.33. And for this one, you get 92.7 divided by 0.6. 154.5. So the total weight is 1869.88 plus 1282.33 plus 154.5 tons times 1,000 kilograms per ton. So 33067110 divided by x equals 11.46. So x must be 288,543. That feels too high. Combined. No. It does feel way too high. I'm not sure. What do I reckon the cut score is going to be this year? I'll tell you after the stream once I've got a gauge. It feels quite similar to last year, you know. I got 28 last year. I think the cut score was 25, wasn't it? Or 26? It'll probably be 26 for outstanding. For scholarship, it's usually like 18, 19, something like that. You never really tell though. This feels too big. Someone yell at me in chat if that's wrong. At large events, recycling bins should be conveniently located to encourage recycling and reduce litter. As part of event planning in many city. Okay. One particular event, Hastings event attendees were found to be on average person will inappropriately discard their recycling. Oh, okay, that's like a level 3 distributions question, right? So 10.5 meters is the average, and if it's more than 12 away, they discard, right? So probability x is greater than 12. This is equal to, if you go to distribution, normal, continuous, so your lower equal to 12, your upper equal to, I don't know, 1,000. Standard deviation 2.75, a mean of 10.5, the probability of 0.2927. So 5 people attending this event in Hastings. All 5 people recycle their waste by using the bin. Um, okay, so the probability x is less than 12 actually, is 1 minus this. You go from 0 to 12. So about 0.7072. Alright, actually I just set lower equals 0, upper equal to 12. Hopefully that's good enough. Might be off by a little bit. So that's the odds of someone doing the right thing, and we want that to happen 5 times. So 0.7072 to the power of 5 equals 0.1769. Yeah, that seems like good enough to me. Discuss. It's fine. Yeah, should be loading. Yeah, all good. Discuss any other assumptions you made. Okay, well the key assumption here is independence, right? The key assumption is independence of events. One person choosing whether or not to recycle properly has to be independent of the others. This is unlikely, as in a social gathering, people tend to follow trends. If one person recycles properly, it may encourage the others to follow suit. And the converse is true as well. It's true as well. If this is not true, then the estimate is wrong, since for non-independent events, their intersection doesn't obey probability of A. Probability of A times probability of B equals probability of A and B. That's only true. This is only true if it's independent. Only true if independent. Only true if independent. So if it's not independent, you can't just to the power of 5 the whole thing, because it's just going to fall over pretty quick. Doesn't work. All right, that's that actually. Good speedrun, I reckon. That was good. That was a good last question. That's fine. Hopefully that's correct. All goods. Probably you could write more there if you wanted. Can't be bothered. I couldn't do this without the diagram. Whatever. That's fine. It's a fine answer there. I mean, obviously I am writing much more condensed, right? I expect this answer would take up most of the room. That seems fine. That seems all fine. Interval. Square root of fuck all. Yeah. Look at that. It's a shame that these graphs weren't visible. That's put 1 and figure 3. Well, it'd be nice if I had figure 3, right? But I don't. So discuss any assumptions. Independence, right? It's just always independence. Okay, that kind of does it. I reckon the cut score will be 26 for outstanding and 19 for O, if I had to guess. She put a gun to my head and made me guess. That's what I would say. Stay tuned for physics. For those of you who don't know, I got top scholar in physics last year, so I'm definitely going to speedrun that. There's no stupid graphs in there, which you can't see at least. And I think it'll be good. I think that'll be real fun. So that's going to be, I think, next Tuesday or next Wednesday. Yeah. But anyway, I think I'm going to leave the stream there, everyone. If you have any final comments, I suggest you type them in chat now. I might just close on this. It's kind of scary seeing the 2025 up there. Doesn't feel like very long ago since I was doing that. Alternative account, I think you'll be fine. As long as you answered everything. By the way, like, I might not have got everything right, of course, you know. Like, it's very possible. It's very possible I caked it somewhere along the way. But, we hope not. Anyway. Yeah. Right, okay. That's that. Goodbye, everyone. Hope you're having a good one. Cut off a scholarship was 17 last year, was it? Huh. Really? Shit, alright. I reckon it'd be fuck, really? I guess it depends how they mark it. No idea. I mean, last year had a bit more probability calculations. There was like a three-circle Venn diagram, and there was even a quadratic and shit. So I reckon it was kind of, people found that a bit hard. Yeah. So this year I reckon it's a little bit easier. I reckon it'll be 18 or 19. But you know, you can score quite a few marks, and it is surplus marked, I think. So you can get 8 marks for a section without actually nailing the section. But yeah, no, I'm gonna leave the stream there. I think I'm gonna go and listen to some music. I think. Yeah, and yeah, that'll do me. Goodbye, everyone.